part that Jason was showing is really helping us to improve that workflow. This is just another example. This is in the Middle East, in Kuwait. It's for the university there. They have a new convocation hall, and it's an X-shaped building. So basically, what that means on half of the facade, it's part of a sphere, but the other half of the facade is a ellipsoid. So one of the things you immediately probably can guess is that, well, for this part of the facade, all the panels are repetitive, at least per row. But on this half of the facade, all of the panels are, well, at least close to the, they're geometrically unique. So to just make this a little more challenging, this is a multi-layered system. So we have like a rain screen with those ellipsoid panels on top. Obviously, we have substructure. We have some roofing panels that are all triangulated, and then we have a space frame and relatively elaborate interior panels made of GFRC. And so here you can see a little bit. It's not only like an ellipsoid panel, but it also has like a pattern. Here you can see the substructure again. Typical example of the roofing panels. So what we typically do for those types of projects, we schedule all those coordinates, and that's basically part of the deliverable, and space frame, and the interior panels. And one of the things we did here was we obviously started in Rhino. We put this whole thing in Grasshopper. We did some optimization with R, which is a statistical language, and that was how we did the optimization of the ellipses. So what we did in this instance was, like, because it was a rain screen, we could accept a gap, and we basically fit similar, ellipses that were not perfectly fitting, but almost fitting into the place, and therefore we were able to reduce the number of panels from like